Absolutely. So, as the title states there, where it begins. So we always have to have a datum point for anything that we're machining, correct? And it cannot be more important to the longevity of the valve seat, that the valve guide actually control that. And so, you can't produce accurate valve seats if you don't have a very, very accurate guide to begin with. It's the reference point. So in many times in machining, we look at maybe head gasket locating dowels, the dowel pin that locates the transmission. There always has to be a reference point. The crankshaft center line is super important to the block. But when we think about the, valve being able to seal combustion, we have to have that great reference point of the valve guide. So remember, the guide is the guide, not the seat. So um, that's where we sometimes falter in our machining practices. So we don't spend enough effort on making a good guide. So we go and cut the seat. The machines will cut the seat, but it just won't be the reference that we need. And then we can have excessive run out and so forth. Um, so when machining the guide bore should be finished without any tearing of material. So which means good tools. You do not want out of round or taper. The desired methods to finish the guide is honing, and they're because reamers can just kind of follow the path that they're given. So of course you bore or ream initially, and then you can do the really uh, close tolerance finishing. So in all machining, and I'll refer to say crankshafts or camshafts, or we rough grind and then we finish grind, then we polish or lap. And that's kind of what you're doing here when you're looking at the valve guide if you do a finish home. So it's just truing up the surfaces. And again, that is true of like a crankshaft housing bores and so forth. Um, there are hand tools and machines that can finish home guides to an accurate diameter and surface finish. And Anthony can definitely speak to that because that's something that they've put a ton of effort on in the past few years.
Yeah, we at Robbins we've been working on developing valve guide finishing machines for quite a few years now, and we have a number of machines out in the marketplace, different types of engine builders using them. And this particular machine shown in this picture is able to do all the different kind of valve guide work. Some people are oversizing existing valve guides, 4 or 6 or 8 thou. Some heads don't have removable valve guides, so this machine is able to core drill out the parent material so that valve guides can be installed. And then, of course, the final process of honing the valve guide is done as well. We have some users of this machine who's starting to use cross-hatch finishing inside the bore of the valve guides. And we're hearing people are able to reduce the clearance between the valve stem and the valve guide because they're able to not only control the diameter of the valve guide, but also the surface finish of the valve guide. And the less clearance between the valve stem and the valve guide, the better valve control and the better performance, and of course, the longevity of the valve guide and the valve stem.
Yeah, absolutely, because straightness is paramount. And so I know that you've done a lot of presentations on cylinder bores, and we talk about measuring cylindricity. A bore gauge is a 2 point method. I can measure diameter and stuff, but I could never truly measure if that guide was banana shaped. And that's one of the things that is quite the conflict when you do just reaming, is that you can produce banana shaped holes. So you can imagine if it's a banana shape and I have a big long valve stem that's going through, there are going to be points of contact. So how do I get rid of those points of contact? We usually make them bigger. But if we make them true, straight, round, we don't have to run bigger clearances to accommodate things of that nature. So yeah, there's a huge opportunity to improve the guide sizes, clearances, and again, that datum point that we were talking about earlier by honing the guides.
Okay, well, let's go on and talk about the valve seat and some of the details on what goes on in the valve seat. And Chuck, would you like to take this?
Sure thing. So the purpose of the valve seat is combustion seal. So in an opportunity to take advantage of that, in the performance world, they have some very, very high seat angles. So 55 degrees. What that does is increase the wedging opportunity of the valve to the seat. So that's going to increase the opportunity to make a seal, a very fine line contact. But the downside to that is the valve can actually want to kind of stick in the in the seat if the materials aren't matched. But again, that's very, very common in the performance world. Secondly, or you want to transfer the heat from the valve head into the casting. So going back to that guide, that's going to help you control the valve seat runout or concentricity. That is going to be paramount in that transfer of heat. High temperatures can be um, helped by having like water flowing around the valve seat area. In that illustration, you'll see like the red arrow is showing that would be like a water jacket behind the seat. So as coolant flows around that area, it exchanges heat with your cooling system. So it's very important that you have good seat to valve contact, just as you should have very good ring to bore contact, because an engine is quite the experiment of thermodynamics, right? So every uh, part that's getting hot has to exchange heat with another part.